Hello everyone, welcome to the 11th part in this series on how to create your very own multicolored research-based code-playing program. So I have a slight update since the last part. Those places in the source code that has been updated I'm now about to demonstrate. So the generate play out move has changed a little bit, and here it is. Yeah, hold on a sec. Yeah. So now when engines try to save its own group, assuming the length of liberty is equal to exactly to 1, it would avoid like extending to the board edge, because that move would result in a capture anyway, so to not waste time and effort, okay, and not give some points to opponent. Also, when the engine is trying to surround player's group, it would try not to surround on the board edge if possible, but would be returning the random choice from all the other liberties available. And similar for extending its own group, it would try not to extend to the very first board edge lines. Okay, and also the generate candidate moves has changed significantly. So now it's trying to use the playout moves as the policy. And this loop over 10 moves, over 10 times. So here we loop 10 times, and what's the idea? So say the generate playout move returns a single move like to capture. In this case, it would be just returning the capture, like here, and there is the only move to explore, so this significantly speeds up the search. And same for saving the group. But say when it comes to surrounding the group, so it might return all the liberties that can potentially be surrounded, so that the candidate moves would contain those liberties, and the search would try to play out each one and find the best score based on that. In this case, as well as in this case, when engine extends its own group, so there might be different choices. So those different choices would be appended to the candidate moves, right? So that's the idea. And also the playouts themselves. So if I just go to playouts and here, so what I've changed, no longer the diamond of a single color is being filled, so this significantly speeds up the process of playouts. So we had only 10 playouts lasting forever in the previous video. Now we have up to 500 playouts, which takes forever as well, but 500 playouts are much better than 10, so hopefully this makes more sense. So let me quickly demonstrate how playouts are working here, assuming the 9x9 board for now. So just right quit and build. So this is a playout, so we only count stones eventually, and although these stones are like dead, they are counted as white stones, but anyway, the overall result is black wins, which is absolute truth. So yeah, black wins anyway, so we don't care much about that. Again here, black just takes more territory. Good. Here, still black takes more territory. Okay. And still black wins. Yeah, now white wins. So white takes much more territory here. Black wins, now white wins again, and so on. So they are still quite random, but at the same time, the heuristics has been improved a little bit, and also the method of generating candidate moves makes this engine playing a bit of a better game as opposed to the previous part list. It's still it's a very poor quality. It only knows about fighting moves, and random moves I just used to make sure that it does not pass. Okay, so let me get rid of this debugging code. So let's have a look how the Monte Carlo research works when it comes to 5x5 board. So show board C3 the best move. So I can do play and white and b3 and show board and genmove for black. Okay. Do I have 500 playouts or 1000? I'm not quite sure. Okay, now here are the moves that are being searched. So c4 is this one. Doesn't score very nicely. d3. D3 is here. So this move and this move are the extension moves. b4 and b2. b4 and b2 are attacking moves. Okay. So it considers b4 to be the best move. The best score is here. Essentially, this has more visits, and b2 has the biggest amount of visits and the best score as well. Okay, so show board. So now I need to play b4. So play white b4 and show board and gen move for black. And now I think this should be, like 1, 2. Okay, c4 is generated. It's probably not the best move, but let's have a look. Yeah, no, c4 is the best move indeed. So now I do, so he was considering from c2, which is this one, c4, which is this one, the best move, and d3, an extension. So yeah, c4 is the best move because, it essentially kills white. So I'll now try to play c2, play white c2. And the only reasonable response would be d2, just to kill this. Any other response would allow white to play a1 and live, and essentially win the game. It doesn't necessarily mean that it would generate d2. Sometimes it generates another move, and that's quite devastating. But that's the multicolored research, since it's driven by the heuristics, so we can blame heuristics in this sort of thing. So why is that happening? It's because of heuristics. Because when he makes a random playout, like semi-random playout, the randomness of a playout makes it trying moves that would never have happen in the real game, human versus human game. So this affects the result negatively. But we are now about to figure out whether the template of this multicolored research driven by heuristics is essentially working or not. Okay. And I need to say gen move black. Yeah. Sorry, I just need to generate the move here. And d4. Let's have a look. Show board. Yeah, and d4 is a very bad move because he should have considered d2. So let's have a look. So d2 only scored 28%, while d3 even more. So the winning move scored the least score, which is not correct. And again, this is because of playouts, but this multicolored research, things happen, so you can do pretty much anything about this. But anyway, you got the idea. The bigger the board size is, it's not that crucial like on the small board size. So now white already won because after white play a2, no matter what black plays, white would play here, and white would already have the living group, and then white would either kill black because it's quite hard to live here, even if not, just having a living group is enough for white to win, assuming there's board size in the kami. So I believe that makes sense. Now let's have a look at the game on 9x9 board at Sabaki GUI. So I just add the engine, start a new game. Let's play one engine to play white, and I start playing. Playing the center in 9x9 is not the best move, I guess, but I just wanted to attach as soon as possible, and then just to show you how the fight is going on. It's losing fights. Like if I play as a human player, I can easily win. But again, heuristics is the only thing to blame. Yeah, because it plays according to heuristics. And this reinforcement learning kind of thing that it does also derives from the heuristics, from the results obtained by the heuristics. On a bigger board, it takes much longer to essentially to make a move, because play out takes longer because that's the bigger board, right? But anyway, generally, the overall concept should be seen. Yeah, this is very far from being perfect, but at the very least, this is the milestone that we reached, that by improving heuristics from now on, the overall strength might be improved. Also, obviously, many improvements for performance, so that the playout would be made much faster. It's another improvement. But before making playout faster, we essentially need to make sure that it works properly, generates the correct outcome. So double Hana here, I don't think this is the good move. So I cut instantly, and I assume he's supposed to protect this stone. Yeah, otherwise he could have just cut here. For instance, if I take, he makes a terror from this side. If I protect, he just, say, connects here to establish some territories in the corner. It would be much better for white, but since it knows nothing about territory, it's not the case, really. So, yeah. Yeah, by the time it's calculating, let me very quickly check there out if yeah, playouts are equal to 500s now. Yeah, 500 playouts. Great. Yeah, and it extends, which is great. So attacking another stone, and again it should extend. Then I would be extending this stone, and I guess, yeah, I cannot say for sure if this is winning by either side. Say extend, black plays here. So if white Hana, northern black here, and takes. Yeah, so move like, if he goes here, if I play this way, black should be dead. But it doesn't necessarily mean that the engine would find the right move. Yeah. So, hold on a second, white is going to be dead. So white plays here, connect. Hold on a sec. This essentially may work. So if, say, plays here, then maybe here. And then if I take, so maybe here. It's tricky to calculate. So let the engine play another move. Let the engine play another move. Okay, he decides to cut. So this is a bad idea, I guess. Or is it? Well, essentially, no, if not these stones, then playing here would have captured black in the ladder. But again, it knows nothing about ladders so far, so the probability of that it would capture your stone into a ladder is very small. And also, if you capture his stone into a ladder, it knows nothing about this. It will be trying to save the stone because of the heuristics. So heuristics needs to know about ladders to handle them properly. Otherwise, it's not going to work. But again, here we are about, at the moment, we are about to discuss the framework itself. Okay, so by the time it's thinking, I'll probably like to mention the last but not least thing. So this entire engine yes, I have nothing to do but this. And now these stones are dead. There is no way to save this stone. If I plays here, I would still give it a chance. I try to play away somewhere so that he could capture these stones. So the template of the Monte Carlo research, driven by the handcraft heuristics that I'm using in this project, is inspired by the Monte Carlo research-based Go-playing program called MCTS, which is the minimalist implementation of Patchy engine. And MCTS takes this exact approach, so it just uses the quite a simple handcraft heuristics, although much better than in my engine. And also, it just gives some bias within the multi-colored research to certain type of moves to drive the search in a more reasonable way, which is also the case. Okay, here Tanuki is here because he probably realizes that it's not literally going anywhere. Okay, just give him a chance. So cut here would result he protects, and I take this stone, and I win everything. But I just want to give him a chance so that maybe he connects, and maybe after he would try to surround this group in future if I Tanuki somewhere else. Again, this does not necessarily mean that it would be to win fine. Yeah, because again, multicolored research is a probability-based kind of thing. It's not the exact precise calculation. And again, if we had imagine we had a perfect playout, yeah, that just does the very perfect game without mistakes. In this case, the data being gathered by the player would be correct. Okay, so just Tanuki here. And if that data is correct, then the reinforcement learning that is done based on that data would also be correct. But if data is not correct itself, it's poor quality based on the poor quality of the playout. In this case, what it has learned from doing many playouts still contains horrible mistakes, because the playouts do contain the horrible mistakes on their own. So that's the idea. So playouts contain mistakes, and the entire results of the Monte Carlo research can also do contain exactly the same mistakes. But the good news here is that at this very moment, the structure of the program has been done in a way very similar to how the MCTS is done, in terms of MCTS also is using, you see, it now tries to attack this. If I take these two stones, obviously he's going to lose, but I give him another chance so that he could capture this, and then he would have a living corner. And then we try to run with this group, and I really hope that it would be capable of capturing this group. So the idea is that, assuming the current template, assuming the current architecture of the program, it's done the way that the source of moves to be played by the engine and source of moves to be played within the given playout is exactly the same source, which derives from the generate playout move. And because of that, we have the only place in the entire source code, which is the playouts. Okay, he takes. And those playouts, oh, okay, hold on a sec. Playing black, I forgot. What have I done? Anyway, I hope you would try to save this group. So I just want to say that by improving the quality of a single given playout move being generated, and with that, improving the quality of this empty triangle is a bad shape. So you may play here and then here and win the game. So assuming the much better playouts, much better quality of moves generated for playouts, we will have more accurate results of playouts, and hence the reinforcement learning, which Monte Carlo research is, essentially also would be better. So this is a bad move because I can just simply play here and kill the next move, but I would ignore that. So I would let him to extend this group one more time. Hopefully he plays here. Okay. So, and again, the way Michi does things is when the play out move has been generated, it has like the type of the move, whether it's a capture or an extension, or maybe that's the pattern matching or something. So the type of move is being defined, and based on the type of move, in the Monte Carlo research, they artificially give some additional visits and additional playouts to. Let me just play away. And additional playouts to the certain node to force the Monte Carlo research algorithm exploring this very node more than other nodes. So that's the way how to bias the search. So essentially, I'm talking about the leverages that are available for us within the Monte Carlo research template. And what in particular can we change to affect the plane strength? So again, just to summarize, the very plane strength on its very own depends on the quality of a playout. So if playout goes too random, in that case, it's not going anywhere. Like the result is not going to be good. Okay, so he decides to extend, but yeah, this is bad. Okay, let me make another dump move. I really hope he will play somewhere in here. Well, essentially, even if I try to surround this one, he will probably still be capable to kill it. Yeah, I could have tried this one. Yeah, really, he could try to kill it. Anyway, yeah. So by making this generate playout move routine, generating better moves closer to reality, taking into account more things, not just fighting, but also taking like territories, maybe some Tsujis, maybe some pattern matching, things like that. This would improve the plane strength. And I've been trying to. Yeah, this is just stupid. Should have played here. So yeah, it's very very far from being perfect, even from being just okay. Anyway, so what I tried with Michi, I tried to take away the pattern matching logic from Michi and try to play the 9x9 game with Michi. And to be very honest, although Michi does, apart from just the bare fighting, it also takes into account ladders. But I managed to win against Michi. Well, not as easy as I can win here, but almost the same. So it's much weaker without pattern matching. So pattern matching should be improving the playing strength by a lot. Okay. Yeah. Okay. Finally does the move. Okay. So here, this is not alive yet. So to be alive, I should also play this move and also play this move. Yeah. So if it would Hana here, this would be just perfect move. I think if it just plays Hana here, it will kill me. If it plays something like this, this would result in Ko. Is that good? So plays this. So white plays here, takes. If then white could play this one, say it takes, and then here, then yeah, it's Ko, but it's impossible for black to live, right? Yes. Yeah, we'll see. And I was quite surprised. Yeah, this is just this doesn't make sense. Really doesn't make sense. Okay, just try to give it an idea that it needs to do something with its group. Yeah, I guess there should be less than 3 liberties, so that engine starts thinking about the defense. I need to check this out, I don't remember. But anyway. So I was quite surprised that while Michi is quite strong when it has all the power in its playouts, all the pattern matching and things like that. But if you get rid of pattern matching, it becomes much, much weaker. So, well, definitely stronger than my engine, but still not as much as, you know. Yeah, it's very strange to me why he does not do anything to this group. I really expect him to. Yeah, but probably he just does a weird move like this, trying to randomly extend while he has to play Hane. But to play Hane, he needs to make sure that this is the group that has least number of liberties. So yeah, what I see here is the dumbness of the heuristics is resulted in such a poor play. But again, since within this engine, all the building blocks we have are essentially placeholders. And I know this sounds like an excuse, and indeed it is an excuse, but my ultimate goal was to, first of all, to create this working template. Yeah, just like I mentioned. Just like I mentioned here. Okay, I just give him one stone here, so that maybe it would then try to kill this. Okay. And then I would try to survive in the corner, which probably is not going to be possible, but just at least to show something. Yeah. So, yeah. Plays extremely poorly, but it's now like clear what to improve. And again, this leverages to control the flow of the engine are now clearly defined. So make playouts better. Okay. And then additionally, you may try to... Okay, if I play this one, he should try to kill this group by playing, say, over in here. Okay. Should kill the group by playing here. So I just want to say that the given structure, the given template behind this engine is sort of similar to what Michi does. And I believe it has potential to be at least as strong as Michi. Although now it's like a base gap between these two. But I think this is possible because like, technologies involved are literally similar. Okay, this is very strange. I have no idea why it doesn't try to kill this group. So it only had 2 liberties before. Any other group... Yeah, maybe the search was resulting in this liberty. I mean, no. I mean, I don't know. Yeah, it's very stupid. I know it's very stupid, but again, what do you want from just the placeholders? Yeah. And since I didn't have a working... Instead of placeholders, I didn't have working pieces. I did not develop them yet. I have no idea how to make those. Okay, this is just so stupid. Yeah, I gave him a chance, but yeah, it just sucks. So it doesn't see that this can be... Okay, maybe if I just... no, even like this, it's not going to work. Yeah, he should have tried to just surround this one. Instead, he just does some very strange thing. The playout. Yeah, so try to extend only if it has less than 3 liberties. We could probably get rid of this. Yeah, we could probably get rid of this. This was a bad experiment, so I could just get rid of this. I'm not going to be trying this for now. I did it earlier. Okay, but yeah, so it just plays absolute bullshit here. But anyway, guys, at very least, at the moment, I can say, like, being sure for at least 90% sure that the multicolored research algorithm itself works as expected, and the method of generating candidate moves also is now much better because it essentially tries play out moves, and if there are many play out moves for a given position, like to extend in different areas and different liberties, or surround in different liberties, all those would be tried and the best move would be found, if any. Yeah, but because of the poor playout logic, it results in a crap like this. So a working template, but filled with placeholders that do not make any sense at all in terms of playing strength. But definitely quite a good playground to stop playing around with, I would say, like that. So at the moment, I'm taking a pause with this project because, yeah, to be honest, I feel very devastated and very unhappy about the result because I thought that even with its placeholders, it should play better. But that probably is biased by my experience with the Enigmax type of searches. With multicolored research, it's vastly different, and yeah, sensing the multicolored research algorithm is very different from sensing the Enigmax search. They are just different, and they need different approaches, different emphasis to be put. So yeah, so I'm taking a pause. I have no idea how long that pause takes. I have many other things to do now apart from this. And to be very honest, this makes me super sick and angry because I don't like when things are not working when I expect them to. But it's not to be blamed. So the only person to be blamed is me because I did this with my very own hands, and my expectations were much bigger than this reality, and I was horribly wrong. But what I can be really happy with is that the basic framework, the basic template for the further like experiments, has been established, and I'm quite pretty sure it's sort of okay. And if one day I would ever bring this to a state where it would be playing a reasonable game of Go, I would definitely make a video on that. But I am not promising this at any point. So at the moment, I want just to throw this project away once and forever and never go back to it. But maybe in the future, I would have some inspiration and make it better. Also, since it's possible in Michi, I know this is possible. I just don't know how exactly it's possible. For me personally, it's very easy when I know when I have the fixed templates of how to do things. If I don't have templates, if I need to come up with my very own, I'm very bad at that. So, like Code Monkey, I can just mimic something that exists already quite nicely, but trying to invent something from scratch that would be working. So this is not about me. So I'm very bad in that. So yeah, and in order to like figure out how in particular what should be changed, how it should be changed, in terms of amount of code, it might not be that much, but in terms of investing time and effort into this, so like researching the Michi engine. So essentially, the next step for me to do here is trying to exactly recreate two things. So the first thing to recreate is how the playout logic is working. So I need I need the playouts to be exactly the same as they work in Michi. That's the step number one. The step number two is to make the candidate moves generation exactly as it works in Michi. Okay? And then I also need to tune the multicolored research to give the certain biases exactly the same as they do in Michi. And in that case, this engine would be essentially Michi. Yeah. So I thought that I can probably do something that looks like Michi but is more simple. But it turns out that practically making something that is simpler than Michi engine results in a crap like this and doesn't have any practical value. I didn't know this before I tried, but now I know. And yeah, this is the unfortunate truth that makes me very angry and devastated. But anyway, life goes on and we need to move on as well. This is from my side, guys. Thanks for watching. Don't wait for next videos in this series soon, but maybe one day. I don't know. Yeah, we'll see. So, yeah, take care and cheers.